Hi everyone. In this video, we're going to continue our review of functions. And so today we're going to talk about inverses and logarithmic functions. So what is an inverse function? So given any function f, its inverse, if it has one, is a function f inverse such that whenever y equals f of x, then f inverse of y equals x. So essentially what this means is that the x and the y's switch places. So if you had, for example, if I have a function that takes 3, 5, and let's say 8, so this is my domain, and then we apply the function f, and so f takes the values in the domain to the range, right? So let's call this the range B, and this is going to be my domain. So 3, 5, 8, so let's say 3 goes to -1, 5 goes to, I don't know, 2. I'm just making these up. And 8 goes to 16. So this is the function. And so we could have a rule for it. I just didn't give the rule. And so then the inverse, what is f inverse going to do? F inverse is going to take the y values, so the range. So I'm going to have my same little circles here. My function machine, they're not very good, but so -1, 2, and 16. So this essentially will take the B now becomes the domain, and then you're going to apply f inverse. And f inverse is going to take, since -1 came from 3, the inverse will take -1 back to 3. And 2 is going to go to 5, and 16 is going to go to 8. So that's what the inverse does. And in order for a function to have an inverse, the function has to be 1-to-1. And so 1-to-1, what does that mean? So for a function to be 1-to-1, that means that every value in the domain corresponds to exactly just one value in the range. So there's lots of definitions here, but essentially, if f is 1-to-1 on D, the domain, if when you have two x values that are not the same, so f of x1 is not equal to f of x2, whenever x1 is not equal to x2. So that's what this is saying. So the y values are not the same when the x values are not the same. So another way to say this is that a function is 1-to-1 if every output has exactly one input. So everything in the range comes from exactly just one input. So let's consider the functions x cubed and x squared. Are they 1-to-1? So if they are 1-to-1, they're going to have inverses. And so let's look at their graphs. Let me move those up a little bit. All right, so we're talking about 1-to-1, and every output has exactly one input. So that means, like, let's look at the y value here. Let's say that this is the y value 8. Right, so this is an output. How many inputs does it have? So 8 has just the one input, 2. Does it have any other inputs? No, right? And notice that everything here has every output, so every y value. So if you look at any random y, this comes from the point, say x1, y1. So there's no other value of y1 in the picture. So that means that it only has one input. So we will say that f of x equals x cubed is 1-to-1. What do you think of x squared? So for x squared, let's look at the y value of 9. Right? Notice that where did 9 come from? What gave us that output? 3. But I also have 9 as came from a different input, from -3. So then this f of x squared is not 1-to-1. So 1 to 1 means every output, so every y value comes from just one x value. So x cubed, yes, any output in here, any y value only has one input. But for x squared, most outputs, only 0 is the only one that only has one input, right? But any other y value, any other output comes from two inputs, the positive and the negative of it. So this is not 1 to 1, which will mean that f of x equals x squared does not have an inverse. So we can say f of x equals x squared does not have an inverse. I know what you're thinking, but Professor Owens, what about the square root of x? Isn't that the inverse of x squared? Yes. So what I'm going to say then here is does not have an inverse on its domain, minus infinity to infinity. However, I can restrict the domain. We can restrict the domain so that it is 1 to 1. To force f of x equals x squared to be 1 to 1. So how do I do that? Well, where we want to make sure that a function passes the horizontal line test. So the horizontal line test means that in order for a function to be 1 to 1, if you draw a horizontal line anywhere on the graph, it touches the graph only once. To be 1 to 1. So looking at x squared, notice that if I draw horizontal lines, this does not pass the horizontal line test. So you can say fails horizontal line test. So the question is, could I restrict the domain, or on what portion of the domain will this pass the horizontal line test? And so the way to do that is we essentially, and the nice thing about a parabola is that it's nice and symmetric. So we can cut it in half and only take half of it to be able to find the inverse. So let's look at what that means. So here I have my y equals x squared, or let me call it f of x equals x squared. So what we're going to do is we're going to restrict the domain to be just from 0 to infinity. So this part of the graph is what we're going to take. And so let's graph that. And so now we can see, now that I have this graph with the restricted domain, that if I draw horizontal lines, it passes the horizontal line test. And so this part is 1 to 1. So I can say f of x equals x squared is 1 to 1 on the interval 0 to infinity. And so passing the horizontal line test and being 1 to 1 means that every output, so every y value, has exactly one input. And in this case, by restricting the domain, we were able to achieve that. Notice that here, going back to our 9, this has two inputs, 3 and -3. By restricting the domain to be just 0 to infinity, now when I look at 9, it only has one input, 3. So now it is 1 to 1. And so that's what we want. In order for a function to have an inverse, it has to be 1 to 1. How do we find the inverse? Right? So now that I have y equals x squared, how do you find the inverse? Now remember what we said about inverses back up here. So the inverse essentially switches the x's and the y's, switches the domain and the range. So that's what we're going to do to find the inverse. So we're going to say switch x and y. So I'm going to have x equals y squared, and then we're going to solve for y. And once that's done, that means that y is f inverse. So I have x equals y squared. So how do I solve for y? Take the square root of both sides. And now I have y equals the square root of x, right? I don't have to do the plus or minus because I restricted the domain to be from 0 to infinity, and I'm only taking, and y's are positives. So I don't need to do the plus or minus because I'm doing that. Well, actually, technically, you will say plus or minus x, but because we restricted the domain and only taken the positives, we will say f inverse of x is the positive square root of x, right, for x in 0 to infinity. And so that is how we find the inverses. How do you determine if a function has an inverse? It has to be 1 to 1. How do you determine if a function is 1 to 1? Every output has exactly one input, or graphically, it passes the horizontal line test. So in the next video, I'm going to do some examples of finding inverses of a little more complicated functions.